Today we're going to be we're still in Chapter 5, Section 2, dealing with trigonometric ratios. Right now what we're going to do is we're going to learn about how to use cofunctions. We have a table right here that we're going to fill, all right? And we're going to start with 30 degrees. So what I want you guys to do is we're going to draw a triangle. You guys should already have a triangle in your journal. So I'm going to make this a little bit bigger, all right? I'm going to make it about a 30, 60, 90. So this is going to be my 30-degree angle. Here's my 60-degree angle. There's my 90-degree angle. Whenever we're doing this, I always shade in which perspective we are going from. So we're going to go from the 30-degree perspective, because in our table, that's what we're going to fill in first. From here, I'm going to draw an arrow going across to label the opposite side. So this is my opposite side. In the 30, 60, 90, I'm going to call this unit 1. I'm going to call the hypotenuse 2. And this side, the distance is radical 3. In the 30, 60, 90, here's the ratios that you can use for any 30, 60, 90, but we're just going to use 1, 2, and radical 3 for the sides. So this is my opposite side. This is my hypotenuse, and this is my adjacent side. All right, so if I wanted to find the sine of 30 degrees, that's the relationship of my opposite side in relationship to the hypotenuse. Well, what is the distance of my opposite side? 1. What's my hypotenuse? 2. So I'm right here. The sine of 30 degrees would simply be 1 over 2. Next one I'm going to move on to is cosine. Cosine is my adjacent side over my hypotenuse. What's the distance of my adjacent side? Radical 3. My hypotenuse is 2. So therefore I have radical 3 over 2. It's not radian, it's not radian. Radical 3 over 2. There we go. Last but not least, let's do the tangent of 30, which is the opposite side in relationship to the adjacent side. What is our opposite side? 1. Adjacent? Uh-oh, we can't have an irrational number in the denominator. What are we going to do? I'm so confused. I like it. Multiply by radical 3 over radical 3. And what does that do to the denominator? It rationalizes the denominator. So now, that is the correct answer for the tangent of 30, right? So right here, we're going to write tangent of 30 degrees is radical 3 over 3. Let's keep moving forward. What are the next 3 that we're going to do? We're going to do the change colors here. The cosecant of 30. We're going to do the secant of 30. And we're going to do the tangent. Not tangent. Tangent. All right. Okay. So Noah, right here, you said the cosecant is what? The
cosecant is hypotenuse over adjacent.
Hypotenuse over opposite. Hypotenuse over opposite. Very good. Ooh, this one's pretty easy. It's what? 2 over 1. Sweet. That's just a 2. That's easy. Let's go over here. The cosecant of 30 is 2. All right. Uh-oh. Alyssa, it's a little bit trickier. We've got the hypotenuse over the adjacent, but I know you can do this. What do we start with? Well, here. Flip. I got 2 over radical 3, but we can't keep it that way, so we have to multiply by over. There you go. All right. So right here, what does that end up becoming, Tori? Good. 2 radical 3. Good job not listening to Taylor there. He's trying to trick you. All right. Over 3. Very good. So we're allowed to have radicals in the numerator. We're just not allowed to have radicals in the denominator, because that would be bad. It would be like crossing the streams in Ghostbusters. Okay? Whatever that means. Alright? So over here, we're going to call this 2 radical 3 over 3. And now we have cotangent. And the cotangent is the adjacent side over the opposite side. Now this is where students kind of do too much work. They do this. They put 3 over, and they shouldn't do that. Actually, they should just take the 1 over the radical 3 and put
Radical 3 over here?
Very good.
Yeah, which is radical 3.
Thank you.
Radical 3.
All right. By the way, make sure you fill in your brother since he's missing lots of days.
Why not?
Yes, you have to. Fill it out. This is what we're doing, by the way. All right, so we have radical 3.
He ain't gonna listen.
Well, you can at least give him an option. All right, so we have radical 3 right there.
Are you seriously trying to teach me how to run out Taylor?
You say yes, just say because I love you.
And he's gonna be like, I'm going inside.
All right, now we're going to learn how to do some things called co-functions. All right, so we're going to have some co-functions that we're going to work with. So, if I say the sine of theta, that will equal the cosine of 90 degrees minus whatever theta is. So let's just use our example of 30 degrees. If I say, what is the sine of 30 degrees, that should equal the cosine of 90 minus 30 degrees. You're right, so that should equal what? The cosine of 60 degrees. So here's what I want you guys to put into your journal as an example. The sine of 30 degrees will end up equaling the cosine of 60 degrees. By the way, what was the sine of 30 degrees in our particular table? The sine of 30 degrees was equal to a half, which means the cosine of 60 should also equal a half. So let's take this information. You guys got it right there? You're going to scroll up right here. 60 degrees. Cosine of theta. Put a half. Because this, what does this part right here represent? This is the cosine of 60 degrees. That will end up equaling a half. All right. Let's try another one. Right? We're going to do another cofunction. So the next cofunction we're going to do is, let's do tangent. Right? The tangent of 30 degrees, all right, is going to equal the cotangent of 90 minus 30 degrees. Put degrees right there. So what it ends up happening, you get the tangent of 30 degrees equals the cotangent of 60 degrees. By the way, what was the tangent of 30 degrees equal to in our table? Radical 3 over 3. So the cotangent of 60 degrees should also equal. So right here, find in your table where it has the cotangent of 60. Cotangent of 60 is right here, so what are we going to put right there? We're going to put radical 3 over 3. So you guys can use cofunctions to fill in the rest of your table. You notice how they're always they're always complementary to each other, right? They always add up to 90. So if I said, what's the cosine? What's the cosine of 30 degrees? What would the, too far. What would that equal as far as sine? That should be the sine of what? Right, which is this particular case. So if that's 30, that has to be 60. What is the cosine of 30? That was what? Radical 3 over 2. So the sine of 60 should also be radical 3 over 2. So we can take this right here. The sine of 60 should end up being radical 3 over 2. Now the only one that we haven't done, I believe, is secant, which goes with also cosecant. All right? So let's go one more real quick. If I say the secant of theta, that equals the cosecant of 90 minus theta. So what was the secant of 30 degrees? That's going to equal the cosecant of what? 60. See how they're always complementary to each other. Okay? So what was our secant of 30? What would we end up getting? Secant of 30. 2 radical 3 over 3. So this also has to equal 2 radical 3 over 3. So let's find the cosecant of 60. All right, we'll take it. The cosecant of 60 is right here. So you're going to write 2 radical 3 over 3. So that's how you use that's how you can use cofunctions to help you find other values. Now, in the calculator, check this out. I'm going to, this is from algebra 2, hit second, plus 712, clear everything out. Now, what I want us to do right now, in order for this to work in our calculator, hit the mode button and make sure your mode is actually in degree mode. Make sure you're in degree mode. All right? And I'm going to prove to you this concept using a rectangle calculator. I said the sine of 30 degrees, we said that was equal to what? A half, 0.5. And that should be equal to the cosine of what? The cosine of 60 degrees, which is also equal to a half. See how you can kind of prove to yourself that this is indeed the case? All right? So if I said, I wonder what the sine of 60 is. The sine of 60 is 0.866. What should that equal? That should equal the cosine of 30. And there it is. By the way, when I was your age, we didn't have nice graphing calculators. All right, I learned that this approximate value is equal to radical 3 over 2. So every time I saw this in my little calculator, I realized, oh, that's my radical 3 over 2. All right, you don't believe me? You just prove it.
Mr. But I don't believe anything you say about that.
Well, I'm just letting you know. I'm just trying to make sure you prove to yourself that I'm telling you the truth.
Probably the smartest teacher I've ever had.
Well, you'll get smarter teachers once you leave.
Oh.
Yeah. So right here, this is a way to prove to yourself that the cofunctions indeed work. Okay? So what I'd like you to do now, everybody, is I want you to go to this and make sure you have all of them. You can do the exact same thing with your 45-degree angle. So your mission is to complete this table in your journal, and when you have it completed, put it